Hello everyone, I'm Askar and I'm going to share a topic on finding dark matter. Dark matter constitutes 27% mass energy of our universe. Without them, our universe needs much more time to form today's huge structure. We can't observe dark matter directly, and we also don't know what they're made of. But we have many fascinating theories on what it is. First, the weakly interacting massive particles (WIMP) has been discussed for a long time as dark matter candidate. It is the hypothesis fundamental particles in Standard Model which only interact with weak nuclear force. Many detections of WIMP collision with normal matter have been made already. By assuming there are dark matter seeds in the space and always collide with the Earth, and we can check the amount of WIMP by annual modulation, which means the revolution direction of the Earth and the Sun are the same in June and different in December. So the number of collisions also changes according to the relative speed of the Earth. Finally, many experimental groups had confirmed there are unusual data that may imply WIMP's existence. However, different groups' data are conscious with each other, which means there are still many problems of the simulation model on finding WIMP. Second dark matter candidate is based on a more interesting theory, supersymmetry. Supersymmetry modifies standard model which can't explain dark matter. It is also used in string theory, the most advanced unified theory. Supersymmetry states every fundamental particles in standard model have their own superpartner. Under R parity, a lattice supersymmetric particle should exist as the last particle in the decay chain. It is stable, neutral, and will last forever, which will very look like a dark matter. However, based on today's technology and knowledge, we are still very difficult to prove this theory. On the other hand, there was another theory which tried to replace dark matter before, the modified Newtonian dynamics mode, which corrects the behavior of gravity in the classical physics rather than adding dark matter to our universe. It estimates the velocity of orbiting stars with a low acceleration, which is related to the cosmological constant. Under this estimation, the velocity becomes independent with the star's distance to the center, and the equation looks exactly like Turner-Fisher relation, which is well confirmed in the last century. It can explain why galaxy rotation curves are different from theory. However, MOND was abandoned by scientists before because it can only explain the phenomenon in galaxy scale. Fortunately, ideas of superfluid has been introduced recently and save MOND. It states MOND effect equation looks similar with superfluid equation. Superfluid is a fluid that goes around absolute zero, and it has high density, no internal friction, quantum correlation that span over long distance, and behave coherently. And the reason why MOND effect only exists in galaxy scale is because dark matter only becomes superfluid state in galaxy scale, while it is fluid state in other scale. Only the low temperature and deep enough gravitational pull in galaxy can fulfill the superfluid condition, and it provides a new force to the star by interacting with them, and it makes the galaxy rotation curve. As a result, we can also see coherent motion in galaxy while incoherent motion in galaxy cluster. This new approach combines MOND and dark matter model. Finally, we have to admit that no one knows what dark matter really is now. But the more important is like what Albert Einstein said, knowledge is limited. imagination encircles the world. It lets us imagine how our world looks like.